Okay, so here is lesson 4. It's going to be kind of a quick lesson. It's just front and back, and a lot of it is you practicing it. It does have a different way of solving quadratic equations or quadratic expressions, splitting these up, factoring them, so that'll be good. But to start, I want you to just try factoring these two, see what you can come up with. I will say this one you can distribute out a common factor first. This one it's going to take some time and guessing and checking. So just give them a shot and see what you come up with. Okay, so on the opening exercise A, so it's 2x squared plus 10x plus 12, and we can pull out a 2 from each one of those. So when we pull out a 2, we have x squared plus 5x plus 6, and this is when we can start to factor the way we've been doing. So different factors of 6 are 2 and 3, 1 and 6, and then just figure out the combination that will add up to 5. That's going to be 2 and 3. So you leave the 2 on the front, put an x in each parentheses, and then you're going to put 2 and 3, and it doesn't matter which one you put them in, as long as it looks like that. The other option is to leave in the 2, and then you're working with different numbers. Other alternatives could be 2x plus 4 or 2x plus 6. Those are different alternatives, but the easiest way is to pull out the 2. So this one here, there's nothing they share in common, so this one's going to be a little bit trickier, and we need them to add up to 5. Also with this negative here, means we'll be multiplying a positive and a negative. So this one's a little trickier. You actually end up splitting this 6 up as 3 and 2, not 1 and 6. So 3x, 2x, and again you have the same factors for negative 6 as we had up here for 6. So when we look at these, it's actually going to be 2 and 3 that we'll be working with again. And if you played around and guessed with them, you would end up with 3x minus 2, 2x minus 3. The reason is, or not minus, it's a plus, sorry. The reason is going to be 3x times 3, so you get 9x minus, so we have a negative 2 times 2x minus 4x. That'll give us the 5x that we want. And then when you multiply through, you'll get the same numbers. So this one is challenging, and this one does take some time to do. That's why they came up with this a different way. That's why you're going to see this today. So it's called splitting the linear term. So normally when we work with these, we have this here. But if you remember, that's a condensed version where we've already, when we factor it like this, we'd write it out. So it'd be 6x squared plus 9x minus 4x minus 6. And so this is the expanded form right here. This is what we're going to try to work back to so that we can solve either one of two ways, with a table or with grouping. So when we're working with equations, they are normally in standard form, and it's going to look like this. So standard form is ax squared plus bx plus c. So a, b, and c are all going to be constants, which is the same as saying they're all going to be a number. When we're working with these equations, it's not going to be you have an a and an x. Normally, sometimes we will, but normally these are going to have numbers, and you're not going to see the a, b, and c. It's like when we worked with recursives and we had a sub 1, that was going to be replaced with a number. We weren't going to be working with that a variable. So this first part, the first step is consider the product of a times c. So the product of, we'd have a times the c, and we're going to look at this one, opening exercise B, to solve that one and show that it this way works a little bit quicker. So we'll have 6 times negative 6. 6 times negative 6 is 36. And then it says, discuss the possibilities that a and c, won't worry about that one. But once we have these multiplied, then we're going to find the factors. So here are all the factors listed out. 1 times negative 36, negative 1 times 36. And all those things that we've been doing up here when we would work with, let's say 6 here, and we try to find the factors of that. So after we multiply the first and the last term together. Then we're going to get the possible factors. And so then we're going to look at these and say, okay, which ones added together are going to give us the 5 that we need, the positive 5. So when we look, the only combination that's going to work is this 9, negative 4. So then we can check negative 4 plus 9 is 5. And so that's how we get our expanded form. So when we determine what these are, then what we're going to do is plug them into the equation. You leave your 6x squared and your negative 6 the same, but then you're going to plug in negative 4, that's kind of an x, and 9, and that's going to also have an x. So then we expand it out. So this is just a neat trick for being able to expand those equations back out and make it so that it's easier to see. So when we're working with these expressions now, we can factor 2 different ways. So the first way that I'll show you is with a table. So with a table, we'll have 6x squared minus 4x plus 9x minus 6. So on a table, you're going to end up having the 4 corners. So you have 6x squared minus 4x plus 9x minus 6. So these are going to be, this is working backwards. So normally we would plug in, or we'd have x plus something and have other things over here. Now when we're working with this, we're going to plug in the terms. The main thing you need to make sure you're doing is that you have ax squared, a bx, and c. You need to have your x squared up in this corner, and then your c, or whatever the number is on its own, needs to be in the diagonal corner. That'll make it a lot easier to work with. And really, if you put the x squared up here, every time you're going to put x on these outsides. So over here, we're going to have an x on both outsides. So we're going to have to multiply something together that's going to give us 6. So our options are 6 and 1, 3 and 2. Well, if we were to do 6 times a fraction would give us 9. But we don't want to work with fractions, and this, we've already shown, works out nicely. So it's not going to work either way. So we're going to work with 3 and 2. So when we're working with and deciding which side we're going to put them on, that's when I'd look at this next one. 4, is it easily divided by 3? It's not. So then we're going to put 2 on this side, because 4 can easily be divided by 2. And the same with 6. 9 can be easily divided by 3, as well as 6. So we'll put the 3 up top. So we have 3x times 2x will give us 6x. So that's correct. Now 2x times negative 2 will give us this negative 4x. And 3x times 3 will give us 9x. And then we just check the last one. Negative 2 times 3, that'll give us negative 6. So then to finish this out, you write both sides. So the top part would be 3x minus 2 times 2x plus 3. And that would be it for doing it that way. So the other option is to solve by grouping. So if you have 6x squared minus 4x plus 9x minus 6, and for showing this, I'm actually going to flip these. So we're going to have 9x minus 4x. So when we're grouping, all you're going to do is you're just going to group the first 2 together and the last 2 together. If you are grouping and there's a negative on your x, so it's a negative 4x, then you need to put a plus outside, just so that you know you're adding them together still. So then over here, you're going to factor out a common factor. So both of these are going to share an x, so we can pull out an x, and both can be divided by 3. So we pull out a 3x. So 6x squared divided by 3x is going to give us 2x, and it'll be plus 3. So then we add on this side, they can both be divided by a negative number, so we can pull out a negative, and they can both be divided by 2, so we pull out a 2. So we get 2x plus 3. So when we're factoring by grouping, now we can look at these 2 terms. Do these 2 terms share something that can be factored out? And the answer is yes. This 2x plus 3 is shared within the two of them. So we can factor that out. So we have 2x plus 3. We put that on the outside. And then we look at what's left. So this is gone. This is gone. What's left is going to be 3x minus 2. And if you look, they're going to be the exact same as the ones up above. So either way works, and it doesn't matter where you put these. You can flip them around. I personally prefer this way, but it's really up to you, whichever one you attempt. But those are the two methods that we're going to work with. After you break it up, then you're going to work with either solving with the table, or you're going to solve with by grouping. So on here, there's a couple of examples. I want you to try and attempt them. Just see how far you can get if you're understanding it. And this is a good point here. Remember to always look for a greatest common factor that you can factor out. That makes these a lot easier. So just kind of pay attention to that. Okay, so we're going to attack these and see what we get. So when we have 2 times negative 10, because remember our first step is A times C. So 2 times negative 10, we're going to have negative 20. And we'll look at different combinations. Negative 4 times 5, negative 5 times 4, negative 2 times 10, negative 10 times 2, negative 1 times 20, negative 20 times 1. So those are all different options, different things that we could work with. So now we got to see which ones added together will give us negative 1. And that's going to end up being this negative 5 times 4. So we can expand it back out. 2x squared minus 5 plus 4x minus 10. So for this one, I'll solve with grouping just to show it that way. The next one I will show solving with a table. So with grouping, we'll group these two together. So this top one, the only thing they share is an x. So I'll pull out an x, 2x minus 5. And the second part, they share 2. So plus 2 and 2x minus 5. So if we look, these two share this term, so I can factor that out. So 2x minus 5. And then I can also write out what's left over, x plus 2. So x plus 2. And that would be it. That would be the factored form. If you want to go back, you can check, just FOIL this back out and make sure that you get the same answer. It's always a good practice to check, especially with these, that way you can make sure you have the correct answer. So then this one here, we'll take 6 times negative 20, so we get negative 120. So negative 120, you do negative 120 times 1, negative 1 times 120, negative 15 times 8, negative 8 times 15, 6 times, or negative 6 times 20, negative 20 times 6. There are a bunch of other options, but we'll just stick with this because the ones that add up together to equal 7 is this one right here. Positive 15, negative 8. So we write it back out, 6x squared minus 8x plus 15 x minus 20. So now I'll solve using a table. So create a table. So 6x squared minus 8x, 15x, and negative 20. Okay, so we put our x's up here. When we look, different factors of 6 are going to be 3 and 2, 6 and 1. Neither one of these is easily divided by 6, so that one's probably not going to work. This one is easily divided by 3 as well as 6, so we can put our 3 up there. 8 is easily divided by 2, so we can put our 2 on the side. So then down here, 3x times what will give us 15x? That's 5. 2x times what will give us negative 8x? That's negative 4. 5 times negative 4 is negative 20. So this is our combination here. 3x minus 4, 2x plus 5. So that would work to solve that one. So on to number 3. This one we have negative 4 times negative 1. So the correct one is 4, or our multiplied form. So then our the only options we have is 2 times 2, 1 times 4. So which ones added up will give us 4? It's going to be this 2 times 2. So negative 4x squared plus 2x plus 2x minus 1. So this time I'll show with grouping. So if we're working with grouping, we group these ones together. So negative 4x squared and plus 2x. We can pull out, for this sake, let's pull out a negative as well. So we'll pull out a negative 2x. They can both be divided by 2. They can both be divided by x. The reason I said to pull out a negative is we don't like negatives in the front. It's better if we can just put the negatives with the back if we need to be working with negatives. So we'll pull out a negative here. So when we pull out the negative, you'll get 2x plus or minus 1. And when we look at this one, plus, there's nothing you can factor out, but it's a good practice of, especially with these ones, pulling out a 1 just so that you have it out there. So these two are going to share this 2x minus 1, so we can pull out 2x minus 1. And then we have negative 2x plus 1. Negative 2x plus 1. So that would be it for that. So then this would be what we're working with on this last one. That would be the answer. For this one here, we're not going to solve it. We could, but the only thing here with these ones is when you're working with fractions, you can always pull out that fraction. So if you have x squared plus 3 halves x minus 9 halves, then we can pull out a half. When we pull out a half, that's the same as saying we're multiplying by 2. So we have 2x squared plus 3x minus 9. So then that one's, you can use the exact same method up here. Well, let's just solve this one. So 2 times negative 9 is going to be negative 18. And then the different options we have are negative 6 times 3, negative 3 times 6, negative 2 times 9, negative 9 times 2, negative 1 times 18, negative 18 times 1. So on this one here, the combination they'll give us 3x is going to be these two right here. So then our expanded form is 1/2 2x squared minus 3x plus 6x minus 9. And so then we can solve this one. I'll do this one with a table this time. So 2x squared negative 3x 6x minus 9. So we'll have an x up on both sides. This one is easily divided by 2. This one isn't. So 2, and we'll leave that x there. 2 times 3 will give us 3x, or 6x. X times negative 3 will give us negative 3x. And then we have negative 3 times, or 3 times negative 3 will give us negative 9. So our answer is 1/2 2x minus 3, and then x plus 3. So I know I said I wasn't going to solve it for you, but that would be how to solve it. And if we were saying what is the sides, then these would be the possible side lengths that we're working with, because it's always 1/2 base times height. So this is just kind of, I think it's a simpler way. Your homework, you're going to be working with some instances where it will be like this. Sometimes it'll be difference of squares. You just have to work with different methods, but this one is a really effective way to solve these, and so I would definitely star these and use this method when working with these. So that's all I got for you today.